Welcome to part 2 of the AAVSO guide. In today's video I'm going to be talking about how to use an ensemble of comparison stars when working with the AAVSO format. As mentioned in part 1, the AAVSO format has traditionally supported only a single comparison star. And the only reason that they now support an ensemble of comparison stars is that they have updated their tools to make use of additional information encoded into the notes section of the observation record. So this information includes the average of the ensemble comp star instrumental magnitudes, the average of the ensemble reference magnitudes, and the target star instrumental magnitude. So whenever you have encoded all three pieces of information, you can then make use of more than one comparison star. Now, fortunately, you do not have to do that manually. The Tycho software has been updated to do that for you automatically, so it is actually a fairly straightforward process. So in this video, I want to take just a moment to share with you what that looks like and how you can now make use of more than one comparison star. Now, if you want to follow along with this tutorial using the same images that I will be using, feel free to download this data set from the Tycho website. This is the V0544 Andromeda dataset. It has 100 images. So again, I will be working with that dataset throughout this tutorial. Okay, so to go ahead and get started here, I am going to navigate to List, Add Images, and as you can see, these images have been compressed. They have the FZ file extension. Now, that is not a concern because Tycho will automatically handle the extraction process. So we can select all images and choose Open, and you can see that when you do that, Tycho is automatically extracting the images for us. So we give it a moment to complete that operation, and once it has finished here, you can see that we have 100 images in this data set, and they are each 60 seconds in duration, and they alternate between the B and V filters. Now, I typically like to work with one filter at a time, so I go to Selection by Filter, and to start with, I will choose the B filter images. Now, with that selection, we can then go to List, Remove Unselected. So as you can see, having done that, we now have 50 images all taken from the B filter. So at this point, we now want to proceed with the typical steps in the data reduction process. So that would be calibration, plate solving, and alignment. Now, as before in the previous video, these images have already been calibrated, so we can skip that step. But again, if you are working with your own images, you typically will do calibration. So you would go to Action, Calibrate Images, and supply a dark frame, flat frame, and that sort of thing. But again, here we can skip that step because that has already been done for us and go on to Action, Plate Solve Images. So with that, we apply the appropriate settings, click Start, and give it a moment to complete the plate solve operation. So as you can see, it has found a solution, verifying it, and now it has finished the plate solve operation. So now the last step in the data reduction process is to align the images. So I go to Action, Align Images, give it the appropriate settings, click OK, and then give it a moment to finish aligning the images. So having done that, now we are ready to go to Action, View Images, and as you can see, this is the object of interest. So if I zoom out a bit, you can see the field of view. Now, if you are not sure where the target is in the field of view, you can always go to Photometry, Load Variable Stars, and this will present you with a list of all of the known variable stars in this field of view. So for example, if I click on an entry, it will automatically go to it. So the object that we care about for this tutorial video is V0544 Andromeda. So I click on it, and I zoom in here, and I double click to center it, and I can right click and choose Create Marker 1, and right click and choose Create Marker 2. So these two markers inform Tycho that this is the target object that we wish to measure. Okay, so the next step is to validate the measuring aperture. So you go to Photometry, Modify Aperture Settings, and as you can see, I have chosen 9 pixels for the inner radius, 9 pixels for dead zone, and 9 pixels for the sky annulus. So adjust these settings as needed, and once you have determined an appropriately sized aperture, you can click Close. And then the next step then is to choose comparison stars for the measurement. So in this case, we go to Photometry, download AAVSO chart, and give it a moment to do that. So these are all of the comparison stars designated by AAVSO. Now what we can do is we can still make use of the comp star finder. So this allows us to choose suitable comparison stars. So we go to photometry, find comp stars, and as you can see, it makes use of this list of comparison stars. And we are also able to apply filters as necessary. So you can apply a filter on the magnitude of the comparison star, on the B minus V color of the comparison star, and other filters as desired. So what I typically like to do is to choose comp stars on this trend line that are close to the trend line. So I can right click and choose add to active comp stars, and I'll typically will do three to five comparison stars, and also I'll have one check star. So I can designate this last entry as a check star, and you can also do graph generate data, and this will present a trend line for each of the comparison stars. And what you can see here is that you typically want this to be a nice flat horizontal trend line that indicates that there is not a huge amount of variability in the star. So with that, we have designated now the target object, and we have designated comparison stars. At this point, proceed to generate the measurements. So again, this is the variable star that we wish to measure. And then I right click and choose create photometry from markers. And as you can see, we have 50 data points corresponding to the 50 images. Now, before I go further, I do typically like to save the work in progress. So I go to File, Save to Repository, and I have created a folder here, AAVSO test, and just give it a name. So V0544 Andromeda, and then click Save. So at this point, if we wanted to, we could also graph the data sets. So you can see what this looks like. The title, you can also give it an appropriately named title. So again, this would be V0544 Andromeda. And at this point, we can now proceed to generate the measurements for the V filter. Now we have both the B filter measurements and the V filter measurements. Now if you want to rearrange the order here, you can move the B filter up in the series here, and we can choose graph, plot all sets. So this is what that looks like. Now you can also adjust the vertical axis. So we can give it a fixed interval if we want. So you can see these are the measurements of this variable star in both the B filter and the V filter. Before I go any further, again, I do like to save the progress. So I go to File, Save to Repository, and I can simply double click on the same set that I had before, and it will overwrite with both of these photometry sets. So now I go to File, Export AAVSO, and give it the appropriate information here. And once we're happy with that, we can click on either Export to Transformations or Export to File. So you typically will do Export to File, but if we want to apply transformations, we can click on this option here. And as you can see, this presents a list of all of the measurements that have been generated. So these are 100 measurements alternating between the B and V filter. So with that in mind, you can see that we have encoded the appropriate information into the notes section of the report. So with that having been done, we can also apply the transformations. So we can choose Apply Transformations, and this makes use of the coefficients that we generated in the previous video. And you can see here that the comment line is the original measurement followed by the transformed measurement. So this is a new capability where we can make use of multiple comparison stars, an ensemble of comparison stars, and still apply transformations to these measurements. Now in part 3, I will show how to make use of comparison stars from different sources, for example, from the Atlas catalog. And again, the reason for doing that is that you may have a situation where there are no official AAVSO comparison stars yet provided for a given field. So it's always nice to have an alternate source of comparison stars to work with. So that's about it for this video. Thank you for watching, and see you next time.